a figure in a coordinate plane. Yes, that's what we did yesterday with the N or whatever letter. So the diagram shows a vector. A vector has an initial point or a starting point and an ending point. In physics, they call a vector, they have the tail and the head of the vector. So here's the tail, here's the head, because it's showing the direction. Okay, it's similar to array, but not really, because array goes on forever and never stops. A vector stops because it's telling you which direction you're moving it, and magnitude. Okay, and magnitude telling you how long it is. Okay, it stops at some point. So there is definitely, usually vectors are relative to force whenever you're taking physics, when you do physics. Okay, so anyway, how do I name this? Well, similar to array, I use the starting point and the ending point, but do you remember from yesterday?
Oh, you do the little one.
It's half of an arrow, right? It's just half. That's what it looks like.
Oh. We didn't go over that yesterday.
Might be, okay? I'm sorry. If we didn't, we're doing it now. So this is how you name it, okay? A vector, and the component points, or the component parts, the 5 units to the right is your positive 5, and the 3 units up is a positive 3, and this is how you write it in a vector's component form, right? Do you know that that's different from how you write it as a rule?
Yeah.
Right, we write it differently. We'll go over that in just a second. All right, so name this vector. How do I name this? It would not be KJ, right? And then what's wrong with this?
The little line.
You need the little half line.
Okay, and then write its component form. So what components make this? Well, it starts here, so I go to the right.
3 and then 4.
3, 4. Yeah. 3, 4.
Yeah, 3, 4.
Oh, you're so smart, kid. 3, 4, 5.
Okay, everybody good with this? There are 3 questions on your homework that ask you to name the vector and, well, your classwork, and write the component form for the vector. Easy, first 3? Okay. The next 3 are, you're still translating. You're going to start off with an original figure. It's probably a triangle. And then it's going to ask you to apply each vector. So you'll start off with a triangle like this. And it'll say, okay, apply the vector -4, 2. So what does that want you to do? It wants you to take this point and move it 4, 2. And then take this point and move it 4, 2. And take this point and move it 4, 2. And then you have a new figure. Are y'all with me?
What? No.
Yes.
It's what we did yesterday.
Yes, it is. That's what we did yesterday. Except I drew all the parts. All right, so here the question says, here are the vertices of the triangle. Okay, A is at 0, 3. And B is at 2, 4. And C is at 1, 0. So you got this triangle, right? You got 3 points, they're all joined, right? You okay? And then we're going to translate it using this vector. So for each one of them, I'm going to add 5 to this and subtract 1 from that. And add 5 to this and subtract 1, add 5 to this, subtract 1. Does everybody understand what I'm doing?
Yeah.
Okay, so let's rewrite this as A prime. And if I do this math,
5, 2.
5, okay. That's
That's
very
my height.
it's very short. Okay, and then we go to, it is, 5, 2 is short. 2, 4, and 5, -1 is what?
7, 3.
7, 3, thank you. And that would be B prime. And remember, it's prime. It's prime because we took an original and we translated it. If you do a transformation, you got to put prime. This one is?
6, -1.
Very good, very good. 6, -1. Yes, you are.
Okay, let's talk about approximate.
Okay, now, I did not graph these. Your expectation on your homework is to graph it.
Is it in our book?
It's in your book in a minute. Okay, write a rule. So they want you to look at what's going on in the figure and write the rule for it. Remember, rule is different from the vector in how you write it.
It's like the actual.
But we still need to come up with what are the components, like what is moving, what's moving. So it's going from A, B, C, the blue, to A prime, is it mine? A prime, B prime, C prime in the red. So if you're looking at, you can pick any point. You can pick A, B, or C, but see where it ends up. Good morning, Sis Waddle.
I might have some.
It's the cake.
I love it. I'm so excited. You don't think there's any room in there? Put it in my library. Oh, Jimmy, put it in there. Seriously? Somebody would eat it? I'll keep it cold.
It'll be that way. Oh, okay.
Sorry.
Oh, cool, okay.
There should
Right, okay, okay.
Yeah.
Okay.
What'd they give? Oh, I think I'll bid on that.
Sam, what did you do best?
Yeah.
Dude, I'm totally bidding on that.
I mean, we're.
Okay, if it doesn't fit, just let me know and I'll have to make them down. Thank you. Okay, the small rings, Carly, you get it.
Yeah.
And you say, small room, politely, not like somebody who,
You have to
oh, my video.
You have to say it's a great day to be a bulldog.
And it's a great.
I'm gonna answer like that.
All right. So did you guys think about what's going on? You can choose any of the points. I'm just gonna choose B, okay? So I'm looking at B and trying to figure out how I got to B prime. I'm gonna have to go to the left, 1, 2, 3, 4. So I have to go -4
And up, plus one.
and up 1. Okay, so if I wrote it as a vector, it'd be -4, 1. That's easy. As a rule,
X minus
nice.
Y plus one.
Don't forget, you start with x, y, and write the arrow. Okay, this is the process for writing the rule. You gotta write the whole thing. X, y, and then it becomes x -4, and what'd you say, y plus 1?
Yes.
Okay, everybody good with this?
Very.
All right, we're good?
I'm
I love
great.
it.
I can do this.
Okay.
I'm
Randy, are
happy.
you good?
Watch this is like the
Okay,
quickest.
now, this one says graph. Okay, I'm not gonna graph them because I feel confident that you can graph them yourselves. But what I can do is apply the rule to the points and then you can go graph all the points. So if I started with A, -1, 2, and I applied this translation, okay, also let me talk about terminology. It says for its image. Okay, an image, like if you're taking a picture with a camera, the original is the person, right? The image is the second thing that comes from it. What I'm trying to say is, image is your A prime, B prime, C prime. That's the image. The pre-image is what came first, is the original, like the person actually standing there. Does that make any sense at all?
Yeah, kind of.
So here's my pre-image. My image for this point after this translation would be,
2-1. I'm pretty sure. Yeah, 2-1.
does everybody know how those numbers came to be?
The image.
So we took -1, and see this rule, it says x plus 3. So we're gonna add 3 to the x, and we're gonna -1 from the y.
Oh.
So see where this +3 and the -1 came from? And that's how we got our image. Okay, I'm gonna try to use the correct terminology. All right, for point B, which is at -1, 5, pre-image, image B prime would be, all right, I have to apply the +3 and the -1,
Give me my Gatorade.
2, 4.
I thought
Yes? Everybody with me? Lainey, you with me, hon?
you were saying like images are gonna like.
That's good. No. Oh my God, Olivia.
That's fun.
What?
Yeah.
I'm drinking all my drink.
Don't, come on. All right, let's go to the next one. Y'all are boring me. Okay, can you name the vector?
Yes.
BK, not KB?
BK.
BK, and then what would the component form be?
What's component mean?
That's the vector.
Oh.
5, 2.
Negative
Count that fast.
I guess.
I
I saw that it was more than 4, so I was like,
-5. Because we went left, so it's negative.
So smart.
Negative 5 too.
Is that a thing?
I can do some.
So can you translate it using this vector, or do we need to do this one?
We can do
We
it.
can
It's
try
fine.
to do it.
We can do it. We don't need that. We can do it. Taylor wants to do it 'cause
Okay.
she wants to show off.
Again, here's one where you're gonna have to graph it. So you graph the figure, you graph the points, and then graph its image. Graph all of the translated figure. You got it?
Yeah, that's easy.
Yes, I got it.
Okay. Now, keep in mind, if you know what the word rigid means, who knows what the word rigid means?
Misshapen.
Misshapen?
Good shape.
Good.
What's it mean?
Shape it.
Like bumpy?
Shape. Spiky. Vertical.
Spiky?
Pointy.
Okay, your mind for what rigid is not correct. What is rigid?
Rigid points.
No. Rigid. Ask Siri. Who's got?
I got it.
Hey, yo, Siri. Hey, yo, Siri.
No, how do you
What
get
is
microphone
rigid?
on a computer?
Hey, get
What is rigid and
What is
math?
rigid?
Well, it's gonna pull up something else.
No, it isn't.
Stiffness is the extent to
Not
which
moving.
an object is
It says
We're angles
large
not
lift
moving.
and formed into narrow raised bands. That's what it says.
Yeah, we
Yeah,
all
that's what it says.
Rigid
Rigid
means
means
How are y'all not talking at the same time?
Mandy goes first.
Oh, but you don't talk at all. Go away.
Stiffness is the extent to which an object is, I don't know.
A shape that can't be pushed to make a different shape.
Can't? Is it saying can't?
Define rigid.
Can't.
Unable
Okay.
to bend.
So unable to bend. If you think about it for just a minute, this is something that it does not change. Rigid could be used to describe some teachers in Palmer High School. Think about it. Stop talking. Think about it. Rigid. Do you have a teacher that's rigid, that doesn't change, that doesn't bend, that doesn't give a little? It's not me.
No, not you.
So think. No. We don't need to say names, but it's possible that you could have a person that's rigid. Think about that for a second. Okay. What you want from furniture is rigidity. You want it to be rigid. What's up, Bob? Good job, sweetheart. You're so pretty. You're so
Oh.
pretty.
What's
Okay.
What number is that 12?
I bet she gave
video,
one
Dookie.
Oh, sorry.
like 5
Some
hours.
call it.
I know, I said Dookie.
I call it.
Okay, so anyway, the point of it is for you to understand that a rigid motion means that it doesn't change. So if you start off with a triangle, or maybe let's say you have an arrow, that's your shape. If you translate it, it's a rigid motion, meaning that arrow is going to be the exact same size and shape wherever you put it. It's going to be pointing upward as well. It's not going to change. Now, we also have reflections and rotations that we'll get to, and dilations that we'll eventually get to, and we'll talk about whether those are rigid or not. But a translation is a rigid motion. It does not change. Does that make sense to you? All right. I'll be... Okay. Also, the composition of translations is also rigid motion. So if you have more than one rigid motion, more than one translation, it's still rigid. What the heck does that mean?
Still.
What does rigid mean?
Still doesn't move.
Doesn't change.
Say.
Doesn't change. Stays the same. Okay. So the composition is when you have two or more translations.
What page is this on?
So how do I do two or more translations? Okay, so let's start with R. Okay, R is at -8.5, and when I translate it, it's going to give me R prime. So what would be after the first translation? -3. 3? Okay, so that's R prime because we did one translation. It's a composition, which means there's going to be more than one. So now I have to take that image, and it becomes the pre-image for something else.
Oh, and
So-
then it'd be like
So is the other one like R double prime?
R double prime, very good. And so now, what are we doing to this point? We're going to -4.
-1.
Okay, now, the thing about translations, when you have a composition of translations, we could actually put them together into one. Okay, we could combine it into one. So what that means is I could look at this
Oh yeah.
and say, you know what, if I go +5 and -4,
Just going plus
I really did. And if I go y -2, y -2, I really did. So that's a composition combined. I think that's what it says, combined. I may be wording that wrong. Look at the very last one.
Adding together.
No, hold on. Okay, write the composition as a single transformation. This is writing it as a single transformation. Excuse me, my verbiage was off. Okay.
You're well.
How do you do that? You just combine them. Does that make sense? Okay. Any questions? All right, we got one more, I think. Yes. If you're doing a favicon for a golf website in an image editing program, you move the red rectangle 2 units left, 3 units down. 2 units left and 3 units down. That's shorthand. And then you move the red rectangle 1 unit right and 1 unit up. So we should probably write these as either vectors or rules or something. What would 2 left and 3 down be?
Negative.
Okay. And we also have 1 right
Plus
and 1 up. So can we combine these into one?
Yes.
-1, -2. Love it. And this is what it would look like in component form. How would it look as a rule?
X minus
X minus
1,
minus
Y
Y
minus 2.
Okay, I think you got it.
X.
So your homework is on page 100 and
L.
101, and you're gonna do, I think it's 1 through 14. Somebody check me on those numbers.
Wait, what was it?
100, 101.
There's 12.
12.
Yeah, 12.
And I want you to do it now. I do not want you to have homework.